Good morning. This is Carl joining you on another segment of Cogitations here on 106.1, the Flip FM. Hope your new year is off to a great and blessed start. And as we kind of come off the hills of having a break from our previous series over the last two Sundays with a focus on what the Bible narrative actually says about the birth of Christ, and then kind of looking at having a new resolve for a new year. We're now going to go into a new series, and I had made mention of this previously on the program, and really answer the question, how can I know? How can I know for sure that there is a God, that He is the creator of the universe? The answer to the question of our origin, both as a species as well as the world we live on and the universe in which it resides, has been the pursuit of countless individuals since the dawn of time. Really, science is centered on that pursuit. It just observes the created universe around it and seeks answers to how it came to be, how it operates with such precision. And this is their ultimate goal, to seek out and to find answers. So, have you ever seriously pursued the answer to the question of origin? Have you ever pursued it? You may have thought about it, dwelt on it, perhaps glimpsed over a book about it, maybe sat and listened to a sermon about it, but have you really dug deep into that question of origin? Regardless of an individual's disposition, the purpose or the pursuit of the answer must be a journey down the road of science. A lot of times we think science and religion are in opposition to one another, but in fact, they are not. There's ideologies that individuals hold within those communities, and even individuals within the same community with different ideologies conflict. But there are those within the scientific community that know and accept the fact that there is a creator. And science actually points towards that. It must be understood that science is not a side in the discussion, but rather the indisputable facts that any argument must stand on. And we're going to talk a little bit more about that, because that's what we're going to focus on, is the facts. The facts that comprise the universe that we exist in. And why this is very important to kind of arm our minds with is while your faith may be solid and sure and secure, imagine if you sat down with someone that had no belief in the Creator, no belief in the higher power. Well, if you pick up the Bible to try to start a discussion with them, you might as well be picking up Shakespeare. Because if they don't believe in a divine God, they're not going to believe the Bible is that divine God's attempt to communicate, because they don't believe in God to begin with. So you have to be able to have a discussion apart from Scripture, yet a discussion that leads to Scripture. Any presented argument that seeks to answer the question that is disputed by proven fact demands that the argument be rejected. And so if you can show how the facts support the divine creator and how the facts refute the other theories that are put forth for the answer to the question of our origin and the creation of the universe, where facts stand in contradiction to theory, the theory must be rejected. But unfortunately, many theories have not been rejected, even though they clash with numerous time-proven facts about our universe and about our own being. Any presented argument that seeks to answer the question that is supported by proven fact, or at the least cannot be disputed by proven fact, demands that the argument be accepted as sound. Now, I like to take an approach as like a forensic scientist. And if you don't understand forensics, a lot of times we watch shows on TV that have the forensic department of the law enforcement out there casing the scene of the crime. And I've worked with several individuals within the forensics community, and it's not their goal necessarily to prove what happened. They will start with a list of probabilities, and as they collect facts, those facts will dispute several of those probabilities. And as they cross them off the list, they will ultimately dwindle down, and the goal is to dwindle down to one that none of the facts dispute. And no matter how improbable it might seem, if it is not disproven by the facts, that's your answer. So before proceeding in any quest for knowledge, one must be willing to identify and separate all the components of any argument into one of three distinct categories. All knowledge, everything that we know, falls into one of these three categories, and they're very simple categories. The first one is what we know. There are things that we absolutely 100% know for certain. And so there is information, there is knowledge that falls into the category of what we know. The next category is in opposition to the first one. It's the counterpart, what we do not know. There are things that we know that we don't know. And we accept the fact that we don't know. We don't have enough information to have the knowledge of what this thing is or that thing is or where this place is or just any number of things. We just don't know. And there's a mountain of things that we just simply don't know. And we know that we don't know. The third one, and this is the dangerous one that gets us, what we think we know, but really don't. There are a lot of things that fall into this category of what we think we know, but we really don't know. We may have even been assured of the information and then later found out that wasn't the fact. We've probably all experienced that in one area of life or another where you absolutely believed something for certain, and then you gained more knowledge and found out what you thought you knew was wrong, and you didn't really know because you didn't have all the facts, all the information. So I'm going to use something for an example. Anybody that's been in school through elementary, middle school, high school has sat in a science class. And at some point in studying earth science, you saw a picture of our planet with probably about a quarter of it cut out, showing the different layers all the way down to the core of the earth. And in general, everybody accepts that. In general, we all believe that that is the structure of the interior of our planet. As opposed to that, and what is presented in pretty much every science book you'll pick up as you go through school, you have the movies. You have the movies like Journey to the Center of the Earth. And it has a whole society living in there, a whole different structure. But we call that fiction. We call that fantasy. But let's talk about the facts. Anybody with Google can look this up. The deepest hole ever drilled into the earth is located in the far northwest corner of Russia, within the Arctic Circle. The project began in 1970 and was abandoned in 1989 due to temperatures reaching 350 degrees Fahrenheit. So if you do the math, that's 19 years there in Russia. They're digging this hole. And if you look online and see a picture of it, you can see how massive this hole is. Because, of course, as you go deeper, it's got to get wider at the top, or it's going to collapse. It's like an upside-down cone or like an ice cream cone stuck in the ground. And so they, for 19 years, with every technological equipment they can have there for excavation, they dug. And they reached a depth of approximately 40,000 feet. You calculate that over, that's 7.5 miles, 7.57 to be precise. So we have drilled over 7 miles, 7.5 miles into the earth. Now let's put this in perspective. The average depth of the ocean is about 1,400 feet, 2.65 miles. So even they've dug deeper than the average ocean depth. The deepest part of the ocean is called the Challenger Deep and is located beneath the western Pacific Ocean in the southern end of the Mariana Trench. Challenger Deep is 35,798 feet, 6.78 miles. Deep based on what is expected to be the most accurate sounding. So let's put this in perspective. The deepest natural cut into the crust of the earth, in their drilling, they didn't even get a mile beyond it. They got a little less than a mile beyond Challenger's Deep. Yet they have not pierced the surface. Let's put this in another perspective. If Mount Everest was placed there, its summit would still be 1 mile below the surface of the ocean if you put Mount Everest into Challenger's Deep. More people have walked on the moon than have journeyed to the deepest depths of the ocean. So what does all this mean for us? What does all this mean for us? The hard fact is that no one has ever drilled through the crust of the earth. We don't have any instrumentation. Yeah, we have technology with seismic instrumentation. I worked for years in sound, in measuring and finding things using sound. But we don't have sound capability that is going to penetrate over 7 miles through, more than that, through the crust of the earth. Thus, no one actually knows what is beyond the crust, much less what the composition of the earth's core is. What is presented as fact in most science books is really just the most widely accepted best guess, or theory, as they call it in the scientific community. They've been so hard-pressed over time to make theory sound better that they actually changed the definition a few years back of what a theory is. But a theory, and we'll look at this in a little while, might be in the next Sunday. But a theory is just a best guess. You look at the information you have, and you guess. You guess at what the answer is, but you don't know for sure. So this is just an example of one thing that, for the most part, people think they know about our world, about our universe, but really don't know. We don't know what's beyond the crust. We gather information, we see volcanoes, we make assumptions, and we lay out a best guess of what's there. But ultimately, we don't know for sure. This example serves as but one of countless best guesses that have become widely assumed to be fact by the uninformed multitude. Not that the multitude is unable to learn, just that they have not been fully invested with the hard facts, but rather misrepresented guesses. It's our goal to move past guessing. Now, everything within science falls into 4 categories, and it's important that we understand these 4 categories and which ones carry weight, which ones need to be our focus. You got facts, you got laws, you got theories, and you have hypotheses. Those who have passed through school, and you might be reaching back in your mind to when you sat in the science classroom, and you remember these terms. You remember being exposed to these terms, and in some of your scientific lab projects, you probably had to come up with a hypothesis and evolve that hypothesis towards a theory and see how that relates to laws, to facts. Well, that's simply what we're going to do. I have some definitions of these different terms, and I got these definitions actually from a science website, so that this is a definition given by a science community. It was actually given by a chemistry scientist. So here's the definition of a hypothesis. A hypothesis is an educated guess based on observation. Usually a hypothesis can be supported or refuted through experimentation or more observation. A hypothesis can be disproven, but not proven to be true. So as you continue to observe a hypothesis, and the hypothesis starts really before you've done anything. You just sit back and say, well, I think since the door has hinges, the door can be opened. That's my hypothesis based on what I observe. And I just say that because I'm staring at the door to the recording studio I'm standing in. And so we have these hypotheses. We see things and we make an assumption on how they work. An educated best guess. But as you get more information, as you actually begin to then examine it thoroughly, you may come to find out that your hypothesis is not true. So what about a scientific theory? A scientific theory summarizes a hypothesis or group of hypotheses that have been supported with repeated testing. So you have a hypothesis or a whole group of hypotheses, because you might say several things about one observation. So you might have several conclusions that are all grouped together, but the theory begins to test them. All right, we have these hypotheses. Now we're going to begin to test them. And by repeated testing, we support or disprove the hypothesis. The theory is valid as long as there is no evidence to dispute it. That is highly important right there. A theory is valid as long as there is no evidence to dispute it. So let's go back to our previous best guess about what is on the other side of the crust of our planet. It's a theory. It is a best educated guess based on what we've been able to observe on the crust. And so we look at the rotation of the earth, gravity. We look at all these factors within the environment, and they draw a hypothesis, they test it, and they come up with this theory, and it's just the best guess. And as we grow in technology, and we might be able to penetrate the crust, send some kind of probe down towards the core of the planet, and might gather new data that just destroys that theory altogether. Some have other theories about what's in the center of the earth, because just like you have volcanoes, you have geysers. You have water everywhere underneath the land. So some actually theorize that there's water. And as the water moves, loose pieces of rock, giant loose pieces of rock, they grind together, and that's what creates the heat that makes lava. Who knows? I haven't been on the other side of the crust, nor has any other living being ever. So we simply don't know. So a theory is valid as long as there is no evidence to dispute it. Therefore, theories can be disproven. Basically, if evidence accumulates to support a hypothesis, then the hypothesis can become accepted as a good explanation of a phenomenon. One definition of a theory is to say it's an accepted hypothesis, an accepted guess. There's a cartoon I saw once. The caption on the cartoon, Junior doesn't know exactly when he's graduating from college, but he's able to offer increasingly educated guesses. And that's what we're doing, increasingly educated guesses with the theory. There's another cartoon kind of going back to hypothesis in a classroom. The teacher is standing over a student, and the student's asking the teacher, when can I stop making wild guesses and start making educated guesses? Sometimes these guesses are just wild guesses, but we want our guesses to rest on as much observation and testing as possible. So let's go on to the law, a scientific law. A law generalizes a body of observations. At the time it is made, no exceptions have been found to a law. So you see something over and over and over and over again, and it can ultimately become a law when there's no exceptions. Scientific law explains things, but they do not describe them. One way to tell a law and a theory apart is to ask if the description gives you a means to explain why. Let's take, for example, Newton's law of gravity. We're all familiar with gravity. Sometimes we trip over our own feet and we become a victim of gravity. Newton could use this law to predict the behavior of a dropped object. You drop the same object anywhere in the world, and it has the same effect. There has been no exception to that unless some other force plays upon that object. But with no other outside intervention, gravity works the same every time. So Newton could predict the behavior of a dropped object, but he couldn't explain why it happened. And really, the why is still a best guess. We don't fully understand the entirety of how gravity works, but it works. And so we can understand the velocity of a falling body, how it moves coreward and not out away from the core. So we observe this law, but it doesn't really answer the question why. But it is as close to a fact as you can get because it has never been disproven. There's no exception to its operation. As you can see, there is no proof or absolute truth in science. The closest we can get are facts, which are indisputable observations. Note, however, if you define proof as arriving at a logical conclusion based on the evidence, then there is proof, air quotes you can't see on the radio, in science. Let me say that again. If you define proof as arriving at a logical conclusion based on the evidence, then there is proof in science. I work under the definition that to prove something implies it can never be wrong, which is different. If you're asked to define hypothesis, theory, and law, keep in mind the definitions of proof. And of these words can vary slightly depending on the scientific discipline. What is important is to realize they don't all mean the same thing and cannot be used interchangeably. So I got all this from the scientific hypothesis theory law definitions, Learning the Language of Science by Anne Marie Helmstreen, PhD, chemistry expert. I was at chemistry.about.com, and you find these theories or these definitions laid out there. There's another little cartoon, has the caption, "We've proven without a doubt that the particle has a negative charge. Unfortunately, an accelerator in Switzerland has proven without a doubt that it has a positive charge." And so nothing's really proven without a doubt when it comes to science. It's just we have come to this conclusion based on all of our current observable information. A scientific fact is an independent and verified description of a link between a cause and an effect that is deducted through observation and experiments and is universally applicable. So a fact is an independent and verified description between a cause and an effect. And when we get into our next Sunday's program, we're going to start looking at cause and effect. It is the basic building block of all of science and the groundwork to answering the question of our origin. Cause and effect. That is deduced from observation. Another little cartoon I like has a lady sitting at a desk, and she has two of those N boxes. One says proofs, the other says theories. The box of theories is stacked to the ceiling. The box of proofs is empty. And it's just another illustration, which is in that comic format, of what we really know. There's a lot of things we think we know. And, we've looked at the evidence, we've observed what we can observe about it, and based on the knowledge that we have, it's the best guess that we can put forth to answer why something is the way it is in the universe that we all live and exist in. With this groundwork laid, it is now time to move forward and examine the question of our origin, not just with intellect, but with strong character. We must weigh into the matter and seek an answer that does not violate the established scientific laws and facts. Laws and facts. Famous scientist Einstein is quoted as saying, "Most people say that it is the intellect which makes a great scientist. They are wrong. It is character." And what he was saying by that is you can have all the intellect in the world, but if you don't have good character, you might put forth false information just to make yourself look smarter, look better, look good, create data that's not there in order to sell your theory or sell your point. A scientist with character, when the evidence disproves their hypothesis or theory, they reject it. They reject that hypothesis, that theory, and begin to search for another answer that fits the data, fits the facts, fits the information. Most people say that it is the intellect which makes a great scientist. No, they're wrong. It is character. Hope you tune in next Sunday. We're going to kind of pick up here where we left off, and we're going to look at the fundamental scientific law that all science is literally built off of. And this will begin really examining the origin of our existence, our entire universe, and ultimately come to only one answer that, no matter how improbable it might seem, no facts, no laws dispute it. I look forward to seeing you again, talking again with you here on 106.1 The Flip FM next Sunday at 9 a.m. Until then, I hope you are blessed, and I hope God watches over and keeps you.